So what's up guys, welcome to Venom Pronov Academy, and in this vid we're simply going to look at the conclusion or the last part of set symbols, and then in a jiffy look at set representation. So we looked at some symbols, but we didn't finish looking at certain notations in the previous vid. So some of the symbols that we didn't look at are this, I'm not so certain about this one, but I think we looked at this one. Symbols like this or this, and then we've got symbols like this or this. Yeah, then we've got complement. Let's say, let me just take into consideration A being the set. We've got this, and other symbols like this symbol, it's like this actually, and this symbol. Okay, so the first symbol is simply trying to tell us the union. It's simply trying to tell us to unify things, and to unify things is simply to group them. So let's have two sets as the sets that we are taking into consideration. Oh, and by the way, there's this thing that we call the universal set. Others you use this letter. Actually, you can use any uppercase letter, not only these. You're not only limited to these, but in most cases you're going to see these being used interchangeably like that. So we are going to have two sets that we are going to use as examples for us to discuss what this is simply supposed to mean. So let's say set A contains elements A, B, C, D, and E. Okay, then we've got set B containing elements A, D, E, and F. So if they say A union B, what are they telling you? When they say A union B, they're simply telling you to get all the elements in set A and all the elements in set B and put them together, then form a set that is comprising of the elements from both sets. But it is not only limited to two sets. It can be as many sets as possible based on the number of sets that you have taken into consideration at that particular time, or based on what the question requires of you. Okay, so in this case, if we unify this, we are simply going to have A, B, C, D, E, F. Of course, we are not repeating elements that are occurring in both sets. We just write it as one, right? Yeah. But what does it mean when they say A intersection B? To intersect is simply to look for elements that are common in both sets, or that are common in sets that you are taken into considerations. And again, it's not only limited to two sets. It can be as many sets as possible, or it depends on what the question requires of you. But I'm simply trying to tell you it can be A intersection B intersection C. It's not limited. Okay, so in this particular case, what we are simply going to look for are the elements that we can find in both A and B. And if you look, we know that A is found in set A, and it's found also in set B. We also know that D is found in both sets, and E is found in both sets. So we can have A, comma B, sorry, not B, but comma D, and comma E. So this is our intersection. So to intersect is simply to look for elements that are common in the sets that you're taking into consideration. Okay, then we've got the power set. So if they say the power set of A, then this is simply the aspect of subsets. I'll reserve this for another vid when we start looking at the power set in detail and all that, because it's simply an issue of a power set. By definition, we are going to define it as a set containing all the subsets of a particular set, including the set itself, because we made a point previously to say a set is a subset of itself, but it's never a proper set of itself, right? But the formula that you use to find the number of subsets is simply 2 to the power n, where n represents the number of elements of that particular set. So n, open brackets A, and this simply tells you the number of elements of a particular set. In this, we can say A. So when you talk about the power set of A, we are going to calculate it as what? 2 to the power n. How many elements do we have? 1, 2, 3, 4, 5. So this is going to be to the power 5, which is 2 times 2, which is 4 times 2, 8 times 2, 16 times 2, 32. So this is going to be 32 elements, subsets that we are going to have in this particular set. But when you are calculating the proper sets, you substitute 1. So to calculate the proper sets, you say 2n minus 1. Why? Because a set is never a proper set of itself. So you substitute 1. So the number of proper sets or proper subsets is simply going to be 1, the number of subsets. It's going to be 1 less the number of the subsets of that particular set. Then we've got these symbols. These two symbols simply denote such that. They simply mean such that. If you want to make an expression and say x is such that, x is a member of natural numbers. Okay, or if you can say x is such that X is a member of natural numbers. This basically means the same thing, and we are simply going to appreciate this knowledge when we start looking at set builder notations, which is set representations. And we've got an empty set, and remember we said an empty set is a subset of each and every set, and it's also known as a null set. Okay, now as in now, a null set, our pronunciation might be different on this one, but NULL. It's an empty set or a null set, and it can be represented using these two symbols. Then we've got the complement. So if we say a complement, then we mean elements that are not found in A. So complement is simply coming to change the narration of the story. If we are talking about all the things or all the elements or members of set A, then we put a complement. Then we are talking about all the elements that are not found in A. All right? Then we've got this meaning equal to, this one meaning not equal to, this one meaning set equivalent. And remember we said sets can be equivalent but not equal, but all sets that are equal are also equivalent. Then these two symbols, they're basically going to denote set inclusion, not set inclusion, but element inclusion and exclusion respectively, where this means it's a member of, this one means it's not a member of. Then this represents the universal set. The universal set is a set containing all the sets in discussion at a particular time. Okay, so this is where our discussion on set symbols ends. All right, now let's